in the x direction. Okay, this is the shear induced by Tx. Okay, now we are now going to look at the shear force that is going to be induced by Vz. Okay, so if the shear force is induced by Vz, right, we know that at element 4 and element 2, the shear flow is in this direction. Okay. Now, element 1 and 3 will have 0 because Q is equal to 0. The first moment of area equal to 0. Okay. Whereas element 2 and element 4 is not equal to 0. Okay. So now we know that we no need to consider element 1 and 3, because over there naturally Vz is not inducing any shear stress. Okay. Then we look at, okay, we are going to look at the moment about y-axis, which is equal to 1160.6, or normal stress induced by the moment about y, which is equal to 1160.6. What we know, right, for element y, right, element 2 and 4 will be 0, right? And then element 1, due to moment about y, will be under compression. This will be under tension. Okay. And then if we look at moment now, moment in Z is equal to 373. Okay, it's equal to 373. All right. So if we look at 373, moment in Z, element 1 and 3 are equal to 0. Right. And then what we have is element 4 is going to be in compression mode. Over here will be in tensile mode. Okay. So for this case, we are going to look at element 2 and 4. Sorry, we are going to see whether should we use element 2 or 4. The answer is to select element 2. Why is that? If you look at the Q at element 2 and the shear stress due to the torque in the x direction, they are in the same direction. Okay, so for this case, the shear stress due to the shear force plus by the shear stress due to the shear flow. Okay. Now I don't know why the shear stress, I do apologize. Shear stress due to the torque in X plus by the shear stress due to the shear force. Okay, which is Vz. Whereas for this case, all right, this is the shear stress due to the torque in the x direction. Okay, so because it's in opposite direction, the shear stress due to the torque is minus by the shear stress due to Vz. Right. So element 2 will have a greater shear stress magnitude than element 4. Right. So for this reason, we are going to select element 2 for the analysis. Okay, because of this reason over here, because of the reason that the torque in the X, the shear stress induced by the torque and the shear stress induced by the shear force are in the same direction. You add them up. Okay, so that is what we are going to do. Okay, so now there's a formula. What we are going to do is to include the shear force. Okay, so what we are going to do down here is, as I mentioned, just to recap, we are going to calculate the principal stresses. Okay, so now we are going to look at element 2. Okay, we're going to consider element 2 at point D. Okay, element 2 at point D. So we are going to calculate the torque first, or the shear stress due to torque. Okay, so the shear stress due to the torque in the X direction is equal to TR over J. Okay, and we know that the torque is 596.831. Radius we know, because the diameter we choose is between. So what do we know? Okay, we know that torque is equal to 596.831 Newton meter. Radius is equal to 26 times 10 to the power minus 3 meters, because we are going to use the diameter that is equal to 52 millimeters, right? So J is equal to twice of I. Okay, I is equal to pi over 4 R4. Okay, so pi over 4, radius is 26 times 10 to the power minus 3 power 4 is equal to 26 power minus 3 power 4, 26 power minus 3 power 4 times by shift pi divided by 4 is equal to 358.908 times 10 to the power minus 3 meters to minus 9, sorry. Okay, 2 meter power 4. So from here we can calculate. So this is 596.831 radius divided by J, which is twice of I. Okay, so 358.908. So the torque, 596.831 times 26 power minus 3 divided by 2 divided by 358.908 power minus 9 is equal to 21.618 times 10 to the power 6 Pascal. Okay. The next thing we're going to do is we calculate the shear stress due to Vz. Okay, which is equal to VQ or VZQY over IYT. Right. So we already got the I value. We know what is Vz. So Vz is equal to 2487. Let me confirm that. Vz 2487. Okay. Thickness is equal to 52 times 10 to the power minus 3 meters. Because the thickness is the diameter of the shaft. So next we need to find Qy is equal to A Z bar. Okay. The area is equal to pi r squared over 2 because it's half the area. The Z bar, if you look at the I have to get out the document that was in your term test, has that formula. I can't remember now, but we can find the value quickly. So this is your term test 1. Oh no, sorry, this is your quiz. Come on. Term test. I should have done this earlier. Test 1. So the centroid, the so-called the y bar is z bar is 4r over 3 pi. 4r over 3 pi. Okay, you cancel this, you cancel this, you cancel this, you cancel 2. So in the end, it's 2 over 3 r cubed. Okay, 2 over 3 r cubed. So this is equal to 2 over 3 multiplied by 0.026 power 3. Okay. So 0.026 power of 3 times by 2 over 3 is equal to 11.717 times 10 to the power minus 6 meter cubed. Okay. So from here, we know that this is 2487 multiplied by 11.717. IYY is 358.908 times 10 to the power minus 9. The thickness is 52 times 10 to the power minus 3. So 2487 times 11.717 power minus 6 divided by 358.908 power minus 9 divided by 52 power minus 3. So it's 1.561 times 10 to the power 6 Pascal. Okay. So some of you might see this oh yeah, the shear stress induced by Vz is low. No, we cannot stop here because it's controlled by the principal stress. Okay, because at the end of the day, this is under compound loading, and the principal stress can tell us whether what is the combined or what is the normal stress due to the combination of the applied shearing stress and normal stress. Okay. So from here, we also have to calculate the average normal stress. Okay. So if you look at the normal stress will be generated by 373. Okay. 373. So only MZ will generate the stress X. Okay. So stress X is equal to MZ over IZZ multiplied by Y. So we know that MZ is given to us as 373. The radius is 26 millimeters. IZZ is equal to 358.908 times 10 to the power minus 9. Okay. So it's equal to 373 times 26 power minus 3 divided by 358.908 power minus 9. It's equal to 27.020, okay, or 27 times 10 to the power 6 Pascal. Okay. So now